So where we left off before lunch is that we're going to solve for side B first because it is the smaller side. And how we are going to do that is we are going to use the given angle, the given side, and then determine this side relationship to that angle. So what is B relative to angle B? Opposite, adjacent, or hypotenuse? Opposite. So then we look at our givens. We've got adjacent, we've got the angle, and the first side we are looking for is opposite. So we've done the first two steps. Started with the angle, bam. Identify the side relationship, opposite and adjacent. And now we're going to decide on what trig function describes this relationship. Folks, we have OA. Is that sine, cosine, or tangent? It is tangent. So we are going to set this up as tangent of 18 degrees. So tangent of the angle is equal to opposite over adjacent, or B over 100. So how are we going to solve this for B? Times by 100. And then it's calculator time, baby. So multiply by 100. And I'm going to write the 100 out in front. We don't typically write the parentheses here, but it can be helpful if you're trying to figure out how to type it in on your calculator. So just like it's log of something, square root of something, it has to be sine, cosine, or tangent of something. So it's only the 18 that goes inside our tangent function. So to type this in, we'll do 100. Then your tangent button is right above this parentheses here. So 100, tangent, 18. And as we stated before lunch, we're going to be rounding to the hundredths place, so 2 places past the decimal. So we've got 0.49. We look at 1 digit further to see if it's enough to bump us up. Is that 1 going to bump up that 9? Nope. So 32.49. So side B is 32.49. 0.49 what? Meters. Very good. So they won't always give you a unit of measurement for your sides, but if they do, be consistent and throw meters on there. Awesome. So now we know that B is 32.49 meters. Now from here, what can we do to find the remaining side, or side C? Pythagorean theorem. So now that I have 2 of the 3 sides, we can use Pythagorean theorem. Now if you're going, it's not super great that we're using a rounded answer to calculate that. You're right, but it's going to be rounded no matter what we do. So better to just use Pythagorean theorem than try to do a trig relationship again. So once you have 2 out of the 3 sides, you can just straight up use the Pythagorean theorem. So a squared plus b squared equals c squared. So a is 100 squared, plus b is 32.49 squared equals c squared. And folks, if I were you, I would put that whole thing in on your calculator. You don't want to do any intermediate rounding between steps, so I would either show it like this or use your stored answer on your calculator. So square root of 100 squared plus 32.49 squared is 105.1 what? 15. So the third digit is enough to bump us up. So the 4 changes to a 5. So 105.15 meters. So personally, I like to label things with the variable letters, but I'm pretty sure on the answer key, I label it directly on the diagrams so you can kind of see if that matches your work. So I've shown it both ways. So I've written it on the diagram if you want to check yourself that way, but I've also used the letter label so you can check yourself that way if you just want to box your answers as you solve for them. So totally up to you on how you want to show your final answers for those on the homework. So folks, let's go ahead and take a look at our next problem. We want to solve this triangle, which means finding all the angles and all the sides. So I like to start with the angle since that's normally the easiest thing to determine. How many angle degrees in a triangle? A total of 180. So if this is 5 degrees, and what's this one? 90 degrees, I can find out this one by subtracting 90 and 5 from 180. And let's go ahead and label our diagram. That has to be angle C. This has to be side C for the right angle and the hypotenuse. I'm going to put angle A on the top, which means side A goes opposite from it, angle B, and then side B. So then our angle B would be equal to 85 degrees. Oh, angle A, my bad. Angle A. So 85 degrees. So again, you can write it down here or write it on the diagram. Sorry about that. Angle A. That's a terrible, terrible A. All right, folks, now from here, we need to figure out our sides. Similar to the last problem, we only know one of the 3 sides, so we're going to try to use our given information as much as possible and solve for the smallest side first. So we start with the angle. What angle do we want to use, 5 degrees or 85 degrees? 5 degrees. Why? Because we didn't have to do any calculations for it. It shouldn't matter as long as 85 degrees is right. It shouldn't matter which angle you use, but as a general rule, it's always best to mark the given angle. So our given angle is B. That's 5 degrees. Our given side is B. Would you say that that is opposite, adjacent, or hypotenuse to that angle? It's opposite. So this is our step 2. Start with the angle, usually given. Identify the side relationships for the given information. And which side do I want to solve for first? Or who is smaller, side A or side C? Side A. Side C is the hypotenuse, so that's the bigger side. So we're going to start with the smallest side first. And again, folks, this is going to create consistency for rounding so that all of our answers match. So let's go ahead and mark side A. Is that opposite, adjacent, or hypotenuse to angle B? Adjacent. Wonderful. Because side C would be the hypotenuse. So solving for side A first, if I have OA with opposite and adjacent sides, what trig relationship am I going to use? Sine, cosine, or tangent? Tangent for TOA. So tangent of the angle, 5 degrees, is equal to opposite 2 over adjacent A. Now, a lot of times this setup really throws students. They're like, the variable is on the bottom. So flip of what we had over here with the variable on the top. How am I going to isolate that A? Sometimes students say, well, let's divide by the 2. That does get rid of the 2 on the top, but we still would be left with the A in the denominator. So when you have a situation like this, we first want to focus on getting rid of the fraction and getting the A to ground level. So we're actually going to multiply both sides by A. That gets rid of our fraction and gets our A to ground level out in front. Now, how are we going to isolate A? What's connecting that A to that tangent? Multiplication. So we're going to divide both sides by tangent 5 to give me what side A is equal to. And we are now ready to turn to our calculators to take 2 divided by the tangent of 5. And that gives us, rounded to 2 decimal places, we've got 0.86. Third digit is a 0. That's not going to do anything for us rounding wise. So 22.86. 22.86 what? Feet. So 22.86 feet.
So wait, is it 2 divided by?
So 2 divided by the tangent of 5. Is your mode in degrees or in radians?
Probably.
And folks, if you're wondering how different it would be, I'm just going to show you what would happen if you had it in radians. If I change my mode to radians and do the exact same calculation, we get a negative value. Is that a big red flag for us if we're solving for a side length? Yeah. So mode first, especially if you're using one of my calculators, I'll remind you guys, but
Change the mode.
Go to mode, hit the mode button right next to the second key. And then 4th item down, press enter on degree, and then it will be highlighted, and then you're good to go. And second mode to quit and go back to the home screen. All right, folks, so the last thing that we need to do is solve for side C. Use the Pythagorean theorem and round to 2 decimal places. I'm going to turn you loose on this one. So check your rounding very carefully. Make sure that you used your stored value here. So I did 22.86 squared plus 2 squared, got this, and then I square rooted that exact answer, and then I don't round until the very end. We want as little error as possible. Third digit is enough to bump us up, so it becomes 22.95 feet. All right, folks. So solving the triangles, it's a little bit harder. Start with finding the missing third angle, and then use a trig ratio to find one of the missing sides. And once you know 2 out of the 3 sides, then you can use the Pythagorean theorem. So SOHCAHTOA, Pythagorean theorem, those are the only formulas you really have to have memorized, and the rest becomes pretty intuitive the more problems that you do. So what's nice about these bottom problems is we're going to be solving for theta on these. Why can't I just subtract from 180? We only know one, well actually, yeah, we only know one of the 3 angles. I only know that this is 90 degrees. I don't know what the other 2 angles are. So it's kind of like getting stuck here. Can't use the Pythagorean theorem because I only know one of the 3 angles. So in a problem like this, we actually follow the same steps above. We start with the angle. So which angle do we start with? The marked one. And then we determine our side relationships. What is 8 relative to theta? Opposite, adjacent, or hypotenuse? It's opposite. Great. What is 15 relative to theta? It is adjacent. How do I know that it's not the hypotenuse? Because it's not across from the 90-degree angle. So if I have OA, which trig ratio am I going to use? Sine, cosine, or tangent? Tangent again. So we have OA. So tangent of the angle equals opposite 8 over 15. Now here we are trying to solve for theta. Back in geometry, when asked, how do I isolate the theta, kids? What do you think geometry kids say to do? They say divide by tangent. That's as silly as saying dividing by the log or dividing by a square root. Folks, if I have the square root of x equals 2, can I divide by the square root to get rid of it? No. If I have natural log of x equals 2, can I divide by the natural log to get rid of it? No. What do we have to use? Inverse operations. So what's the inverse of square rooting? Squaring. The opposite, the inverse operation would be 2 square both sides. What's the inverse of logs? This is a little bit trickier. Exponents are the inverse, so I would rewrite this in exponential form. Big animal ears. E squared equals x. It's tangent to the negative 1. So folks, I can't divide by tangent. I have to use the inverse of tangent, which is tangent to the negative 1. Tangent to the negative 1 is how it's written, but how it's stated is inverse tangent, both sides. And lucky us, we can see that inverse tangent is a function on our calculator of second tangent. So if I hit second tangent, that gives me inverse tangent of 8 divided by 15, and that gives me the angle. Let's see, and that would be 28.07. What? Degrees, because it is an angle. And we're not solving the triangle here. We're just looking for our theta. So that's it on that problem. These problems used to be awful for you guys in geometry. Just the worst thing ever. It's like, what is an inverse operation? But as you can see, now that we've done so much stuff with square roots, now that we've done all the stuff with logs, it's like, oh, it's an operator. Like, yeah, you can't just divide by sign. We'd have to do something opposite to get rid of it. So folks, I want you to try example 4. Mark the angle, determine the side relationships, determine which trig function you're going to use, and see if you can solve it. Mark the angle. What is 31 relative to theta? Is it opposite, adjacent, or hypotenuse? It's opposite. What's 36 relative to theta? It is adjacent, but it's across from the 90-degree angle, so that's hypotenuse. So what trig function are we going to use? Sine, because we have SO, or O and H. So sine of the angle is opposite over hypotenuse. How do we get rid of sine to solve for theta? We inverse sine both sides. So inverse sine, 31 divided by 36, and we get 59.44 degrees. Yeah, inverse sine, sine to the negative 1, second sine. That's your inverse operation.
Why do you do hypotenuse instead of adjacent?
Because we don't know the adjacent side, so to use our given information, we're only looking at what we already have.
Question.
Yes.
How do you get negative 1 in?
So to do the inverse trig function, you do second sine, if it's inverse sine that you need, second cosine, inverse tangent. So similar to how squaring and square rooting are second features of each other in your calculator, natural log and base E, log and base 10, like those are all inverse operations of each other on your calculator as well. So folks, that is it for notes for today. So in your homework packet, on 4, 5, and 6, round to the nearest hundredth. This is important because rounding is a large part of this test. On this one, you're solving for just 2 trig functions. Make sure you're using exact values for those, no decimals. So that means leave it in radical form as you are doing the Pythagorean theorem and all that fun stuff. So on 7 and 8, exact answers. The rest rounding to the hundredths. On page 2. You're only solving for the unknown angle x, and you're rounding to the hundredths place. On 11 through 14, you are solving each triangle, so finding everything, the missing sides and the missing angles. You have to show work on these. I should be able to tell where everything came from, what trig relationship did you use, or what does your Pythagorean theorem work look like. Those ones you are rounding to the hundredths place as well. So folks, for tonight, just 1 through 14. Yes.